Hello again lah. Let me check first if everyone are here already. Okay, Noel, it's okay. Farah, Lim, Shah, Russell, Jeremiah, Noel, Wong, Daniel, Elvin, Celine, Jonathan, Nathan, Wong. Okay. So, everyone, I hope you all had your lunch already and then you are ready for this lecture. Okay, so if you all remember, last week we have already learned about user interface design. So, before we proceed to our next lecture, I will give the mind map actually for all of our chapters that we have learned previously up until our last semester lah, our last week after this. Okay, so these are the mind map, and then where we are now later, we will see from this mind map. Okay, so first, at the early weeks, when we have first started learning about software engineering, so we have learned that the process of SDLC, as you all know, there are about 7 general stages. Okay, it is started with initiation, analysis, after that design, coding, testing, and lastly the maintenance. 1, 2, 3, 4, 5, 6 lah. Okay, so some of the categorization or some of the article will say or expert will say there are 7, but some will say that there's 6 lah. But actually, it is more or less similar because the most important thing here is there will be initiation. In the initiation, what we will do is, in our early weeks, we have learned about few software process model that is actually commonly used and practiced in the industry. And then after that, we will learn about all A or SE, but this one will be, we will learn this in our later chapter. And then also as CBSE, CAS, and then a CAS tools software. It is a type of software, but we will learn that later in our chapter 12. And then, okay, so this is the chapter that we have learned previously, where during the SDLC phase, which is the second phase, the analysis, we have already learned about requirement engineering, the process of creating the SRS. Okay, so remember SRS is the software requirement specifications document. The document that you need to produce in order after we have completed all of the software requirement gathering, and then we have do some analysis. We have learned some analysis during this requirement engineering, and then after we have finalized all of the requirement, we come out with one main document, which is actually become, if you all remember, the SRS can become like the basic books or the basic Bible for software development. Okay, so it has become like a contract. It can be read by your end user. It can be read by the developer. It will be used by the developer, and then it will be read by the boss of your end user. Okay, so after that, we will proceed in the SDLT. There's the third phase, which is the design. So under this design, we have cover, and then we will cover the few chapter. So what we have learned last week is the UI design, which is the chapter 8. Okay, so today we will learn about design concept, which is in chapter 9. And then after this, next week, we will learn about real-time system design. And then this one is what we have learned previously lah, the architecture design. So remember the um, structure organization structure that we have learned. Okay, so the fourth stages in SDLC is doing the coding, where we will not cover this because, like I said previously, coding is a huge topic and it will be covered by a lot of courses that you all, some of it you already learned, and then some of it you will learn later. And then after that, we already learned about software testing. So remember, I all said there's a lot of testing. Okay, so and then last is the software maintenance stages, and then this in this stage we will learn about software evolutions, which is in chapter 11 lah. But we haven't covered this. We will cover this in our future lecture lah. So now we proceed. Where we are now is we are here, design concept. Okay, so this one we already have the lecture, and then real time will be next week. Okay, so I hope we all already clear lah. Okay, so there's one actually that there's one topic that we have learned about how to manage the software development. Okay, so that all of that process we will learn in this project management, where the project manager is responsible to handle all of the process that happen in the SDLC stages. So we have learned about that in chapter 3 lah, previously. Okay, so we already know about where we are now. So now we proceed to our chapter 9 for today, which is the design concept principle. Okay, so design concept and principle. So in this chapter, we will learn about few topics. First is the design process activity, and then after that, we will learn about some general guidelines of how to develop a good design. Okay, so after that, we will discuss four common design quality metrics, meaning there are four things that you will need to consider in order to sure that your good design is a good design. Okay, so to know that your design is a good design, it should have these four common design quality metrics. So what are they? Okay, we will learn about that after this. Okay, so we proceed to good design characteristic. Okay, so these are the characteristic of design, a good design. So remember, after you all remember, right, the phases that I just show you just now. So the design process is the design or the stage that you will need to go through after the SRS have completed. Okay, so based on that SRS, you take it and then you read it and then you analyze it and then you come out with the design. Okay, so before we proceed to the design, we should know this characteristic. For a good design of your system, it must implement all of the explicit and implicit requirement. Okay, so in Malay, it is explicit and implicit is tersurat and tersirat, meaning something we need to cover all of the functional and non-functional. So usually the functional is the explicit, the non-functional is the implicit. Okay, correct me if I'm wrong. Maybe I'm also maybe it is terbalik. So yeah, um, so your design, whatever you have designed, and then based on the SRS, you need to make sure all of the software requirement that is stated in the SRS need to be included in your design. It must be covered, meaning whatever the user requested must be covered in your design. If not, nanti you missing some of the important requirement lah. Okay, so remember, it must cover all non-functional and functional requirement. Okay, so your design must be readable, understandable for those using them for coding, testing, and maintenance. So remember, SRS is not only used by the end user. It is not only used by the boss of your end user, but also it will be used by the developer, the one who design, the one who do the coding, and then the one who do the testing later, and then the one who will maintain the software. So all of them will refer to the SRS. That's why the SRS is a very important document. It must have, even though you are using the agile methodology, where in their principle they said that it will only use a minimal documentation in agile, but even in agile they also will make sure that they have the SRS, because SRS is the most important document. Okay, so your design must be readable and understandable. Okay, so design must provide a complete picture of the software, its data, and functional and behavioral domains. So it is not only, the design is not only the architecture of the software, it is also must include the design of the data. Okay, for example, you need to include the design for your database. Okay, so you will need have some important information like that uh, database table or whatever table that is included. What is the attribute included in that table also need to be covered during the design phase. Okay, so the functional and behavioral domains lah. Okay, so these are the three stages of tackling design problem. Okay, so remember, before you start design, you have the SRS first. So after you have the SRS, the first things that you need to do is you need to study and understand the SRS. Okay, so because from the SRS, you will understand the problem or what are the requirement from the user. So after that, you will need to identify the gross feature of at least one possible solutions. So for every functional requirement, for every non-functional requirement, there must be a solution in your design. Okay, so you really need to cover every single requirement from the SRS, and then you need to make sure that in your design, meaning what you will implement later, you will have at least one feature or one solution that will fix or that will serve the requirement that is stated in the SRS. Okay, so after that, the third stage is to describe each abstraction used in the solutions. So later, when during the design, you will have to do a lot of abstraction or diagram, and then each of your diagram you need to describe how it can solve the problem that is requested from the SRS. Okay, so what metrics to be used to measure the design quality? So this one we will learn later. Like in our topics previously, in our agenda today, we will learn the 4 design quality metric. Okay, so we will learn that later. So you for the moment, maybe you can try to think lah, what are the quality that our design must have. Okay, so this is one way that is introduced by the expert on how we should tackle the design problem, meaning how meaning we don't know where to start, right? So when we have the SRS, so what is the first thing that we need to do instead of just looking at the three stages previously? So um, we the expert said that we can use the top-down design. Okay, so we can use the top-down design to tackle the design problem. Okay, so the problem is recursively partitioned into sub-problem until tractable sub-problem are identified. So meaning to say that you think the system as a whole first. Okay, so remember the top down, we see the system as the whole first. After that, we see the subsystem that can be included in the system. After that, we take one subsystem and then we see what are the module that should be included in each of the subsystem. And then after that, we see each of the module, what are the function or the individual component that is needed. So that is the top-down design. Okay? So we see it at the whole first as at the higher abstraction first. And then after that, we move to its individual component or module or subsystem, one by one. Okay, so that is how the expert says one of the way of tackling the design problem lah. Okay, so far so good.
Good.
Pardon?
Uh,
Okay. Okay, so can I have a raised hand, please, before I proceed? Okay, so good, and thank you. Okay, so we proceed to the parallel design activity. So here is the activity, the list of activity and the product from each of the activity. Okay, so thank you all. You can put down your hand. Okay, so this is the activities that you will need to do during the design. So instead of the three stages just now, this is more into deep lab. Okay, so each of the activity will come out with a product, meaning the outcome or the output of the activity will have a product. So the first activity is, this is actually the previous stages, which is the requirement specification. So from the requirement specification, we will need to do architectural design, which is we already learned in our chapter 6. And then after that, abstract specification. Also, this is from the architectural design, if you all remember. And then after that, the output or the product from the architectural design is you have your system architecture from it. Okay, so after that, after you have the system architecture, you can proceed to do the abstract specification because abstract specification will need system architecture. Okay, so after that, after you have done the specification of abstraction, you can come out with software specification. And then after that, you can proceed to the interface design where we have learned last week. Okay, user interface design. And then after that, from that activity, you come out with the interface specification. And then after that, from the interface specification, we can proceed to the activity of designing the component design. So if you already have your architectural design here, right? Okay, so in the component design, you make it by subsystem. Okay, so remember, after a system, the whole system, you have subsystem. Under subsystem, you have a module, and then under module, you have individual component, which is like function or method or procedure. Okay, so after that, but from the component design activity, you can come out with component specification. And then after we have come out with the component specification, then we can proceed to data structure design. Meaning data structure design, this is where you design your database. For example, how many tables you will need, what are the attributes that you will need. Okay. So after that, from this activity, after you design your data structure, then you can come out with a data structure specifications lah. Okay, so after that, we can proceed to the algorithm design. Here, you will go to each of the functional. For example, if you want to do one add function, okay, so the function is only need to do A plus B. So there will we will need an algorithm, even though it is just a very simple process lah, right? Okay, so for example, the first algorithm, it is like pseudocode. Okay, maybe you receive the input A and B, and then after that, the second process is you will need to check either the input is in the correct type. If not, then you will need to output or give some error handling, and then but if it is okay, then you can proceed to the next, which is you can add that two input. So that is the algorithm design. But imagine lah, in your real world letter, the algorithm may be confirm lah, a lot will be complicated lah. It is not as easy as just adding two parameter lah. Okay, so you will need to come out with algorithm for each of your function or module. Okay, so the example of the algorithm is the, like I said just now lah. Maybe you can come out with pseudocode, flowchart. Yes, Jeremiah, do you want to ask something, or it is because you forgot to put down your hand? Okay, so we'll proceed. So from the algorithm, after you have designed the algorithm, then of course you can come out. The product of it is algorithm specification. So here, all of this product is actually, it is based on the company itself. Either they want to come out with just one document that consists of all of this specification, or they maybe have one document, one specification. But usually they will put all of this inside one document lah, which is the SDD, software design document. So it is like another the second document that we should produce lah after SRS, which is SDD lah. Okay, so we proceed. So we proceed to the design activity. Okay, so in the design activity, we will need to use some notation to design our system. Okay, so we cannot rely on only a text. So imagine that if you are describing or designing a house, a terrace house, double story house lah. Okay, so imagine you are describing it using text. Okay, so you will say that in the first paragraph, okay, we are going to develop a double story house. The double story house will have two floor, which is the first is the ground floor, and then the second is the first floor. In the first floor, we will have 3 rooms, bedroom, and then 1 bathroom. And then in the first floor, we will have a kitchen, and then there will be a living room. Okay, so imagine when you are developing a software but explaining it like that. Okay, so no, of course cannot, right? We cannot use all text. So that's why we use notation, because notation will help us understand more about the system. So in this topic, we will learn about the notation that we will use in order to design our software. So there are few types of notation that we can use. First is the graphical notation. So here, in this graphical notation, you will need to create or draw some graphical that will tell the overall picture of the system and the relationship between the components. Okay, so for example, maybe you are developing website, and then you will say that you are using client server architecture. So in order to create the graphical of the client server, maybe you put some server, you put some user, and then it is all connected through internet. So that is graphic the example of graphical notation, because it will show the relationship between each of the client and the server, and also what are the medium that is connecting the client and the server. So the first notation that we can use is the graphical notation. So this one we have no specific no I mean there's no macam a very strict notation that maybe you use. Maybe it is not like a flowchart that it will say that you need to use diamond in order to picture optional flow, right? Okay, so that is in a flowchart. But in this notation, you are free to use any icon as long as it can show the overall connection and the component inside your system. So it is like you are looking your system from above. Okay, so it is must be in higher abstraction. Okay, so for example, if you are building a house, you can see a double story house, you can see only a house with first and second floor. It is like your the graphical notation lah. So in order to picture a house, then you can maybe choose a house icon, and then it will have a divider to show that there are two floor in that house. Okay, so first notation we can use in design document is graphical notations now. Okay, so after that we can use program description language. So this notation will use control and structuring, and then it construct based on the programming language construct. So it allowed the intention of the designer to express, but not the details of how the design to be implemented. So uh, okay, so here it is like a pseudocode. And yeah, so the example of this is the like a pseudocode lah. You use some of the words in the programming. For example, if else. Okay, so in your pseudocode usually you will use that kind of words, right? Okay, so who here that actually familiar with pseudocode? Anybody here? A bit. So Noel, you have used pseudocode previously lah, during some of your courses maybe. Oh yeah. So in the pseudocode you are using some of the programming language, right? The syntax like if else, and then some logical operator. Yes, there's so many ways to write. Okay, but usually, sometimes you usually will use some programming language syntax in your pseudocode. So this is what it means by the program description language. Okay, so after that, the third notation that we can use in the design the document is the informal text lah. Okay, so this informal text is usually the natural language lah. Okay, natural language is the language that we use like now lah. Okay, so it explain nature. The informal language can be used to explain some of the graphical or some of the notation. So this informal text will be used for design that cannot express formally, like non-functional requirement. Okay, so this informal text we will use to explain, for example, like when we say that the system must be give a feedback or the result of the search must be come out within 2 seconds. So we cannot put or we cannot describe that non-functional requirement using any graphical, right? So who can imagine how to express the non-functional requirement that I have said just now in any notation other than informal text? For example, like I said just now, there's a one functional requirement, a non-functional requirement from your user that it says that the search function must give result within 2 seconds. So what are the notation that is used beside the informal text that can best describe that non-functional requirement? Do you have any idea? If no, then yes lah, of course lah, it can only be, we can only use the informal text for that kind of situation where we cannot express that requirement in any notation or graphical notations lah. So we can use the informal text in that situation. Okay, so these are the design activity that we have learned previously, and then what are the notation used to design that activity. Okay, so for the architectural design, we usually use graphical notation to express it, and then for the abstract specification, we use usually the informal text. For the interface design, we can use graphical plus informal text to explain the graphical notation. And then in the component design, we use graphical and programming design language, which is now PDL. Okay, so after that, data structure design, we can use graphical plus PDL. Algorithm design, we can use PDL plus informal text. Okay, so far so good, right? Okay, so far so good.
Good.
Okay, so this is what I said just now about the metrics, because we want to know, because doing the design, sometimes it is very subjective. For example, for the things like the architectural design, nobody will tell you, okay, when they say it, when they saw your architecture, right? Okay, they say that, this is not good lah, this is not good, and this is good. Your design A is not good, your design B is good. So how does people know that design is actually good and then this design is not good? So it is based on some metrics. So in software design, the expert already give some guideline where for the design to be said as a good design, it must have the quality metrics. So in this topic, we will learn about 4 quality metrics that can be used as the measure on how you can say that your system, your design is good. Okay, so based on this quality also, you can tell people, oh, okay, boss, maybe you are presenting to your boss. Okay, boss, I have come out with a design. This design already fulfill all of the quality metrics. So I'm a little bit confident that our design I will produce a good software in the future. Okay, so yeah, so these are the four quality metrics that you can implement in your design so that you are confidently can tell people that your design is actually a good design. So first is cohesion, second is the coupling, third is the understandability, fourth is the adaptability. So the first is the cohesion. Okay, so the cohesion is the component. The cohesion of a component is the measure of the closeness of the relationship between its component. Okay, so a cohesion is a measure of the degree to which part of the program module are closely functionally related. So here, cohesion is the metrics that can measure how close the relationship between each of the component. For example, you have one subsystem. The subsystem is about like student registration subsystem. Okay, so maybe you have one system which is student portal, and then under the student portal you have different subsystem. First, maybe the student registration. Second is maybe course registration. And then after that, the third is the report generations. Okay, so let's say we take that one subsystem, which is the student registration. So inside the subsystem student registration, there will be more than one modules. For example, maybe one module is the student module. Sorry, I think it's better if I give example of the course registration subsystem. So let's say, imagine you take that one course registration subsystem. So inside the course registration subsystem, you may have another modules that is working together to produce that course registration. So for example of the module that may be involved is there will be a student, there will be a course because it is the course registrations, right? The student will need to register a course. So the module, there are two modules that is required for the course registration subsystem, which is student and the course. And then after that, um, so it means that the cohesions in the course registration subsystem is close, meaning the cohesion is good lah, because we have we have group that two module that is dependent or related to each other, which is the relevant module that should be working together inside one subsystem. So we didn't put module for reporting inside the student registration because it can be in another subsystem. So in the student registration, the most relevant module that you can include is the student module and the course module. Okay, so because we have another subsystem which is report, so you don't need to put some. Maybe you want also to input the record of sorry, maybe you also want to include the student report inside the student registration, course registration report inside that student, inside that course registrations module, but it actually it is not really relevant because you already have one subsystem just to handle the reporting. So it is like a duplicate. If you have reporting inside the course registration subsystem, and then you have another report also that is inside that reporting subsystem. So when you have identified all of the relevant component inside one subsystem, and then it is relevant, and then they are related to each other, meaning you have a good cohesions lah. Okay, so meaning to say that you didn't include whatever module that is not related. You only group the module based on their relevancy, their usage lah. Okay, so another definition here about the cohesion is it is like a measure. It can measure a degree. It can measure the degree to which part of the program are closely functionally related. So, like I said just now, lah, if you like the student module and the course module, they are functionally related, closely functionally related. So when you put that two related and relevant and functionally related module inside one submodule, and then you group them together, all of the components inside your system, you group them correctly based on their functional, meaning to say that your system have a good cohesion. So later, if I'm not mistaken, we will learn the level of cohesions. Okay, so here. Okay, so a cohesion, they will have about seven, 1, 2, 3, 4, 5, 6, 7, 7 level. Okay, so among all of this level, functional cohesion is the best. Okay, so when you want to say that your system having a very good cohesion, you need to make sure that you have a functional cohesion. You have implemented the functional cohesion inside your design. Okay, so we will learn about what is each of the level talks about lah. Okay, so coincident cohesion, this is the worst. The first level, which is the worst cohesions. The worst cohesion level lah. Okay, coincidental cohesion is a part of a module grouped arbitrarily. Okay, for example, you group all of your module not because of their function, but you group them arbitrarily. Okay, so for example, you put all of the even it is not related to each other, but you group them all in one utility class. Okay, so you for example, you have one class. Imagine you have various function, and then you created one module which is utilities module, and then inside that utilities module you group all of the functions even though they are not related to each other, but because they will be used in your system, and then you assume that all of them are the utilities function. So even though they should not be in that class, you also put them all of them in one category, which is utility class. Okay, so that is the worst cohesions lah. The worst the worst cohesions lah. Okay, so the second worst cohesion level of cohesion is the logical cohesions, meaning for example, you are grouping the modules inside your system based on logical categorization. Okay, so for example, actually even though this one is mouse and keyboard, let's say you have these two components, but let's say lah, they are not related to each other. Doing they are not working together in order to make something successful lah. Okay, so but we know lah, right? Mouse and keyboard usually working together lah. But in this case, we assume they are not working together. Okay, so but because they are handling the same things, which is the input handling routines, then you categorize them in one category. Meaning the here, right? You are categorizing them not based on the functional of the system, but because of the type of the because of the type of the component. Because this type of component is responsible to do input in in our system, but it is not like I said just now. Just assume maybe in the terms of your system, it is maybe mouse and keyboard is not related to each other, but because of they are handling input, then you categorize them based on this logic, meaning to say that your logic to categorize them is not correct lah here. Okay, so after that, temporal cohesion. So in this temporal cohesion, in this level, this is the third level of cohesion. So in this cohesion, part of a module are grouped by when they are processed at the particular time in program execution. Okay, so in here, for example, you have one module. This module may be a class lah, like just now the utility class, but you put or you group them because of they are run at the same time during the runtime execution. Okay, so this is one is also is not a very good way of designing because you are putting them together just because of they are they are running together during the execution time. For example, here the close open files, create error log, and notifies user. So let's say all of this back-end process is happen during you execute one function inside your system, and then because of they are execute concurrently because you just click, for example, you click save button, and then all of this back end process happen during you click that button. Okay, so although they are actually from different subsystem, when it is close open files, it is from subsystem A. Creates error log, it is actually a background process for subsystem B. And then notifies the user, maybe it is another subsystem that will, it is the background process for subsystem C. But because of they are all executed at the same time during the runtime of the system, so you group them together. So this is not a correct way of grouping all of your module or function lah. Okay, so after that, the procedural cohesions where you group some of your module following a certain sequence of executions. Okay, so for example, a function which check file permission and opens the files. So like I said just now, this is you group them because of the sequence, maybe because the first process when you run that your system, maybe there are a function that will need to check the files permissions. Okay, so that is the first step, and then after that there will be another function that will need to open the files. So because of they are executed in sequence when you click when you run some function inside your system, so just because of their sequence is like that, so you group them in one module. So it is actually not also not a very good way of grouping. Okay, so After that, the communication cohesions, where you group each of the component in your system because they are operating on the same data. Okay, so for example, a module which operates on the same record of informations. Okay, so for example, you have a module to generate report, and then you have a module of registering student, and then that report is actually projecting or generating report about the student, meaning they are using the same table, database table, which is student database. So because of they are operating on the same table or on that student database table, so you are grouping them together, even though they are actually from different subsystem. Okay, so that is also not a good way of designing your system. So it because it is just because it is operating on the same information or because it is sharing the same data. So it is better than the previous, but it is not as best as the sequential cohesion. So the sequential cohesions is where you group the function or module inside your system based on the output from one part is the input to another part like an assembly line. Okay, so for example here the function which reads data from a file and process the data. Okay, so this is more or less similar with the previous cohesion, which is actually this one, procedural cohesion. But this one is because of the sequence of execution. But here it is based on the output and the input of each of the part. For the part here may be referring to a module or maybe a functions lah. So maybe you are grouping that module just because the output from module A is the input for a module B. So because of they are uh, transferring data to each other, then you group them in one group, although they are not in the they are not in the system. So this is better than the communication cohesion, but it is not better than functional cohesion. So remember, the functional cohesion is the best way of designing your design because it is because you are grouping a module or a function inside your system based on the function. Okay, so you are grouping in the functional requirement, you are grouping a single well-defined task of the module. Okay, so for example, like I said just now, the example of the student portal. So you may have one subsystem inside the student portal where the course registration. So in the course registration, you are grouping student module and course module inside one subsystem because that both module are relevant to be grouped together and then it is functionally related to each other. So when you group the module based on the function of that module and how relevant they are to each other, so it is said that you are implementing a functional cohesion inside your system. So when you are choosing what type of cohesion you want to implement in your system, you can choose functional cohesion because functional cohesion is the best cohesion among the 7 levels of cohesion that is suggested by Constantine and Yordle. Okay, so maybe you all will be a little bit confused about each of the level previously, right? Because actually it is the explanation or Yeah, the explanation of each of the level is a little bit deep, talking about some situation during the coding, during the implementation. So you maybe don't really understand. But the most important thing here in the cohesions is you know that there are seven level, and then the best is the functional cohesions. Okay, so the functional cohesion is where you group each of the module or your functions based on the function of the system, not because of the sequence of the execution, not because of the communication of each of the module. Okay, so far so good for the cohesion. Can I have raised hand, please? Yes. Let me see. Okay, so thank you for the feedback. So we are good to proceed to the second quality metrics. I think, okay, just too many info. Yeah, so like I said just now, I have highlighted to you all, there are four design quality metrics. First, we have already learned about cohesion. The cohesion have seven level. And then the most important thing that you will need to know is the best of that seven is the functional cohesion, where you group each of the module based on the function of the module, not because of the previous level tu lah. Okay, so that is the highlighted part lah. If you understand that, uh, okay already. But if you really curious, you can uh, read about that more lah. But like I said, that is the highlighted part. The most important thing for you to understand is the best cohesion level is functional. So if you want your system to have a good cohesion matrix, please choose the functional cohesions. Meaning to say that you group your function, your module based on the function of that module, not because of the previous six grouping. Okay, so we proceed to the second coupling. The second quality metrics, which is coupling. But before we proceed to this, because we are already have a 1 hour lecture, so we can have 5 minutes break. Okay, so we meet again at 3:35. Okay, so guys and girls, we proceed to our second quality matrix, which is coupling. Okay, so in this coupling, this is very much related to cohesion. Okay, so if cohesions is the degree of closeness of each of the module that you group together, but for the coupling, it is the indication of the strength of the interconnection between the component in the design. So, okay, so this is the um, there are two type of the coupling lah. So remember just now cohesion, there are 7 level, and then the best is the functional cohesion. But for the coupling, we only have two type of coupling, which is highly coupled system and loosely coupled system. So for the highly coupled system, it have a strong interconnection among each of the module, and then with program units dependent on each other. And then for the loosely coupled system, um, each of the component are independent to each other or almost independent. Okay, so meaning to say that, okay, from reading these definitions, which do you all think is best for this coupling? Either to have high coupled system or loosely coupled system. Who can make a guess? Okay, Kelvin said loosely. Can I have answer from others? Loosely. Ian also said loosely. Noelle said yes, loose. How about Jeremiah? I know you all have already learned this in diploma, but maybe uh, if you still remember, Jeremiah? Ah, yes, loosely. You shouldn't put the questions mark, oh, Jeremiah. You should put apa tu yang tanda seru because you need to be confident because you are the SF. Okay, so yes, guys and girls, for a coupling, the good type of coupling is loosely coupled system. So remember for the cohesion just now, the best is the functional cohesion. But for the coupling, you need to make sure that the coupling of each of the modules should be loose. Meaning each of the module inside your system, I mean the modules that is not related to each other lah. You should make them independent. Don't, for example, um, for example, in the student portal, you have subsystem, like I said just now, course registration, and then after that, you have reporting subsystem. Okay, so if you implementing a highly coupled system, whenever you change something in the in the course registration, subsystem, you also need to change something from the reporting because that the code between the two subsystems are highly dependent to each other. Okay, so because of they are highly dependent to each other, even though they are from two different subsystems, and then they are actually logically they are not doing the same things, but they are dependent to each other. So it is means that your system have a highly coupled system. So it is not good because in the future when you do the maintenance, whenever there's something problem in the course registrations module or subsystem, you also need to change the reporting module. So it is not encouraged. The one that is good design is for you to implement the loosely coupled system, because whenever you change something, you don't need to bother about another part of the system. You only need to focus to that individual subsystem or module or function. So the conclusion is, for a coupling matrix, you need to have loosely coupled system. So far we have learned about cohesion, we have learned about coupling. So for cohesion, it is best to have functional cohesion. For the coupling, it is best to have loosely coupled system. So when people, or there's in the exam questions, how do you make sure that a design, software design is implementing a good design? So you can say about this cohesion and the coupling lah. So maybe you can elaborate that. For a software design to be said as a good software design, it must implement functional cohesion, or functional cohesion. And then for the coupling, it must implement the loosely coupled system where each of the module is independent to each other. Okay, so now we have covered two quality metrics, cohesion and coupling. Okay, so so this is the difference between cohesion and the coupling. Okay, so because it is so much interrelated, but actually there's a difference between it lah. The cohesion focus on how much the functionality are related to each other within the module, while coupling deals with how much one module is dependent on the other program modules within the whole applications. Okay, so a good cohesion when you group individual component inside the correct module, and then their relationship is very close, and then they are related, functionally related lah. So you group them in one module. So it means it is the closeness, the degree of how you measure the closeness among the component inside one module. Remember, one module. For the coupling, it deals on how much one module is dependent on other module. Okay, so this is cohesions, this is coupling. So imagine that this coupling, this is one module, this is one module, this is one module. For this one, cohesion, it is only one module. Each of this is, for example, one module, and then this is one function, one function, one function, one function. And then you group all of that function that is functionally related in one module. Okay, so that is a cohesion, the measure of the closeness between the function inside one module, within one module. For the coupling is, imagine you have more than one module, like here. Each of these is a module, and then it is the measure on how dependent each module to each other. Each module to each other. Okay, so that but the best for it is, they must be loosely coupled, meaning each of these can hidup sendiri. Okay, so even though one module have a problem, there's a lot of bugs inside one module, this module is not affected. Okay, so understand about the difference between cohesion and coupling, because I can say if you are the first timer to heard about this, then it may be a little bit confusing for you. So now can understand about cohesion and coupling? If no, then you can ask. I will, so might need to revise later. Okay, so how about Lim? got the revise. Okay. Okay, so if like that, then we can proceed. If you have any question after this, you can just apalah, ask in our chat also can, in WhatsApp also can. Okay, so the third quality matrix is understandability. So I think this one is without me explaining it much. I think you all can understand lah what is the understandability. Okay, so the understandability of a design is important because anyone changing the design must first understand it. Okay, so and then there are number component characteristic that affect understandability, including, okay, so this is what we have learned previously, cohesion and coupling. So if you have a good cohesion and then a good coupling, meaning a good cohesion is functional cohesion and then a good coupling is loosely coupled design, meaning your system can be easily understandable lah. So whenever whoever will take over the system in the future, maybe the maintainer, when they read your SDD, software design document, and then they analyze your design on how you arrange the module, the function, the subsystem inside your system. They can easily understand it if you have implemented functional cohesion and loosely coupled system. Okay, so after that, another characteristic that can influence the understandability is the naming. So here, for example, if you name a variable in your system, or if you name not a variable, not only variable, but if you name each of your subsystem or your module car, I mean each of the component inside your system with a useful or understandable terms. Okay, so it can make your design is we can say that your design have a good understandability feature lah. Okay, so after that, the documentation. The documentation is if your documentation is consistent. Consistent, for example, from your SRS, you have used the same term. And then is in the SDD also you are using the same term, meaning they are referring to the same thing. So people will understand it easily. So meaning to say that in terms of documentation, you have to make sure that whatever design that you have designed in the SDD, it must consistent with whatever in the SRS. Okay, so when you implemented it, for example, you said that in your SRS you have one module which is course registration. So when you do the design, you also have one subsystem which is course registration. So it is the naming and it is consistent. Okay, so that people will not confuse. Okay, maybe in your SRS you put that only the name of the module is only course, but in your design you name it as a course registration, so people will not know either they are referring to the same module or not. Okay, they are talking about the same thing or not. So um, you you can say that the design of your system have a good understandability feature if you can the SRS. So beside that, you also need to make sure your documentation free from the anomaly, the missing important information. It should be consistent. Okay, so if you all remember, we have learned about uh, the error in documentation where we will need to validate. Okay, so all of that need to be uh, take into consideration when we are doing the documentation. So after that, the complexity lah. So this complexity actually also still referring to the cohesion and coupling. So if your system, for example, have uh, the level of the cohesion is not it's not the functional cohesion, and then it has a highly coupling design. Okay, so it you can say that the system will be very complex because when it has a high coupling, it makes each of the design will be complicated. So in the future, it also can give a bad time to the maintainer if they need to change something because it is very complicated. When they need to change one part, they will need to change another part. So if they forgot to change the another part, it will cause another error. So you can say that the third metric here, which is understandability, you can say that the design of your system is having a good understandability feature if you have cover all of these characteristics. So, like I said just now, it is a good understandability if it has functional cohesion and then loosely coupled system, and then the naming of each of your component inside your system is meaningful, and then all of the documentation are free from the documentation error like inconsistency, anomaly, missing important part. Okay, so and then the complexity, it is referring back to the cohesion and the coupling lah. Okay, so after that, we proceed to our last design quality metrics, which is adaptability. Hmm. Okay, so this adaptability is actually a general estimate how easy for the developer to change the design of the system. Okay, so for example, maybe they need to change the system because of the new requirement, or maybe they need to omit some of the old requirement that is no more needed. So based on your opinion, how we can achieve the adaptability? Okay, so I will repeat again. The adaptability is the measure. It is actually a general measure. There are no some units, or there are no some level like cohesion, like coupling. We don't have that standard, but it is just your estimation on how easy for the developer to change the system. So based on your opinion, guys and girls, here. Okay, so how we can achieve the adaptability, or how we can make sure that our system is easy to be changed in the future. I mean, the design of the system is easy to be changed in the future. Ah, Okay, so I have some answer here. Mm, Miss Norshikin also participated though. Okay, so Noel said that follow as much standard as possible. Farah said that must have a good design. And Miss Narshikin said easiness to change the code without affecting other module or sub. Okay, so actually, beside them, beside the three of them, can I have another answer from Celine? Okay, understandable file structure. Okay, so Alvin, understandable file structure. So I'm waiting answer from Celine. So Celine, my question is how we can sure that our system have a good adaptability matrix, because it is not like a previous metric that we have some standard, but this adaptability we don't have any standard to say that this have a good adaptability, and then that one is not having a good adaptability. Follow guidelines. Okay, follow guidelines. Okay, so I want another answer from Russell. Russell. Yeah, Russell. How do you think we can achieve adaptability? How do you think we can say that our system having a good adaptability feature? I mean, the design of the system having a good adaptability feature. Consistent with the implementation. Okay. So actually, yeah, some of the answer here is already close lah. Okay, so design should be consistent. Okay, so yeah, Kelvin said low coupling. Yeah, actually, your answer, all of your answer here is already a close. There's a close already lah. Okay. So, for example, here, follow as much standard as possible. So, Noel, here, I want to ask you here, what is the example of the standard that you mean here? Follow as much standard as possible. So, what standard you want to follow here? Like guideline, yes, but what are the guideline? Not sure. Okay. Okay. So, Farah said follow. I must have a good design. Okay. So, Farah, I want to ask you here. What do you mean? What is your definition of having a good design? Everyone can say, right? Okay. So, you must follow good design. But what is actually your definition of a good design? Like a good design so that can be changed in the future. Yes, yes, of course. We need to follow a good design. That is correct, actually. We need to follow a good design to make sure that our system is having a good adaptability. But what is the good design? Okay, so it's okay if you are not sure. I will tell after this. Miss Norshikin said that it is easiness to change the code without affecting the other module or sub. So this is actually referring to the coupling. Okay, so this is referring to the coupling. So yes, okay, so it is correct also. For Elvin, understandable file structure. What do you mean by file structure, Elvin? Yeah, Elvin, what do you mean um, by the file structure? If you all answer like this, kan, in the exam, I cannot give much marks lah because it is there's no much apa tu no it is nothing to I mean it is cannot be give I cannot give high marks lah. Understandable file structure because all entity class organized in entity folder. Organize understandable file structure. Okay, so yeah, actually, even though your answer is not incorrect, but actually it is not that um, lack of explanation lah. Okay, follow guideline sheet. So my still in. So my question is like similar with Farah just now lah. What is the guideline and similar with the Noel just now? What do you mean by the guideline? What guideline need to be followed? Okay, so Russell, consistent with implementation. Design should be consistent. Design should be consistent. Consistent with what, Russell? Design should be consistent with the implementation. Okay. So design is should be consistent with yes. I can agree with Russell. Okay, so Kelvin actually answering the same like Miss Norshikin, which is actually low coupling. Okay, so Miss Norshikin also referring to the low coupling. Okay, so no more answer. So yeah, actually all of your answer is macam already there, but it is not too really accurate. Okay, so because what I want to say is for your system to have a good adaptability, it must have another three metrics just now that we have learned previously, which is actually some of it already answered by Miss Norshikin and Kelvin, the low coupling. And then Russell also because you see you are actually um, referring to the understandability like in our understandability previously I have mentioned about the documentations, right? So all of the documentation must be consistent. So yes, so to 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 make sure your design of your system having a good adaptability feature, we need to make sure that the three of the quality metrics that we have learned previously is already implemented in the design so that for example the low coupling whenever you want to change anything in the future you just only need to change that affected module without bothering about other module. And then for the understandability, yes, also like what Russell said, that documentation must be consistent with the implementation. So and then the documentation also must be um, free from the documentation error like anomaly, ambiguous, sorry, not anomaly, the ambiguous terms, ambiguous requirement. It is also need to be free from the inconsistency, from the missing information. Okay, so all of that lah, whatever that we have learned previously, we need to make sure that the three component of the three quality metrics must be implemented in our design in order for our adaptability metrics to be in order for our system to have a good adaptability feature. So we can say that, okay, boss, I have implemented adaptability, meaning to say that our system in the future, if there's any changes if there are any requirement needed in the future, we can easily change the design because I have already implemented functional cohesion. I also have implemented. I mean, the design that I have designed is actually supporting the loosely coupled system, and then I also have already make sure that all of the documentation are consistent. It is free from any documentation's error. It is also having. It is also not too complex because I already implemented the cohesion, functional cohesion, and the um, loosely coupled system. Okay, so all of that quality, the three quality previously, if you already implemented it, then you can say that your system or your design having a good adaptability matrix. Okay, that means that your system will be easy to be changed in the future. Okay, so far so good. Agree ka? If no, then you can say why you are not agree. Okay, so can I have raised hand, please? Okay, so thank you for all of your feedback. Okay, so we proceed that. Okay, so we have done with. Okay, so this is actually what we have said just now lah. The system should be loosely coupled, like what Ms. Narshikin said and Kelvin said, and then design should be well documented, like what si Russell said lah. Okay. So after that, the component also should be easily understood. All the component documentation should be easily understood, and the design should be consistent with the implementation. Okay, so this is what we have discussed previously. So, in short, like I said just now, for a design to be said that having a good adaptability matrix is it should also all of the three metrics just now is already covered. So it is what is actually explained in here. Okay, so another way of how to achieve adaptability is the program implementing the system should be written in a readable way. Okay, so uh, in the naming lah, if you remember the naming, all of your module of your all of your variable, and then maybe you should put some comment in each of the functions of your system when you do the code. Okay, so We have covered the quality metrics. So remember, we have four quality metrics that we need to make sure implemented in our design so that we can confidently say that our system is having a good design. Okay, so beside that for the quality metrics just now, this is the guidelines for good design. Okay, so um, design is not coding, coding is not design. So that means when you do design, don't think about the code first because the design should focus on logical way of how you should of how the system should operate or behave. Okay, so when you doing the design, don't think how to do the code first because if you think about the code first, you sometimes you will forget about the logic because the design you need to design your system in the higher abstraction first without going into the details of the code. Okay, so coding is not design because coding is just the implementation whatever you have designed. Okay, so that is what it means by design is not code, code is not a design. So when you do this design, don't think about the code first because sometimes your design it will be limit or your imagination will be limited just because sometimes when you are the programmer lah, and then you are doing the design. Sometimes when you do the code and then you don't know actually as a programmer not all of the language you know how to do it, and then not all of the technology, especially for the newer technology, even though people said that technology is a good a good technology need to be implemented in the system that you are going to develop, but because you don't know about that technology, or maybe for example you are a MVC programmer, mobile model view controller, sorry, for example, you are a programmer, but you are tied to the old way of programming. For example, you are only familiar with the structured way of programming. And then suddenly MVC come. And then people say that MVC is very good. It support object oriented. Okay. This type of system that you are going to develop is actually suitable to use MVC. But because you don't have enough knowledge about MVC. So you still stick to the structured way of coding because you are refused to use that. So it will limit your design, although your design actually can be designed following the MVC. So because of your limitation in coding, because you are already think about the coding, so you lose the logic. So that's why it is when you do design, don't think about the coding first. And then when you do the coding, you no longer need to do the design because in the coding you only need to walk the talk. Whatever you design, you need to implement it. Okay, so the second guideline is the design should be assessed for quality as it is being created, not after the fact. Meaning to say that's why we learn the four quality metrics just now because we need to make sure our design is already followed all of that four quality. So that quality we need to during the design we already assess the quality, meaning we already implemented that four quality, so that after that you no longer need to think about the quality because after the design you only need to implement it. Whatever you design, you implement it. So you don't need to think about the quality of your design when you are doing the implementation because it is already done during you design the software. Okay, so after that, the third guideline is the design should be reviewed to minimize conceptual error. So this is the example. The error here is the example of the documentation error. For example, the omission. Omission meaning there are some requirement or there are some information that are missing. Ambiguity when there are some either requirement that is ambiguous, or there are terms that actually can be interpreted different way by different people understand it uh, differently. Another different excuse me. So another person understand it differently. So ambiguity meaning one terms or topic or requirement can be interpreted differently by different people because it is like a subjective. For example, like you say, mm, apple, apple lah. I know apple is not something like we are usually use in our software design or software um, in development of software, but this is the example of word ambiguity lah. Ambiguous word. For example, apple. Okay, so when people say that, okay, in your during your birthday letter, your father lah, maybe your father promised to you during your birthday letter, I will give you apple. Okay, so what is your imagination of the apple? Maybe you are thinking about, oh, maybe my father will give me apple lah, iPhone. Okay, so maybe your mother will think, hey, you will be your father will give you a buah apple too. Okay, so that is the terms, the example of ambiguous term, which different person can interpret it differently. So if your document having that kind of term or that kind of requirement that is actually not, it is very subjective, it is not specific, so it is also it that kind of error need to be reviewed, or that's why your all of the document or all of your design should be reviewed to minimize that conceptual error. So, and then the inconsistency, like I said just now in the SRS, you only said that you have course subsystem, but in your design tiba-tiba you have mentioned that you will have course registration system, so people will not know which is actually the correct name of that subsystem. Either it is a course only or a course registration subsystem, so it is example of inconsistency. So when you do design, somebody need to review all of your designs so that all of these kind of error need to be can be minimize. Okay, so after that, the fourth guideline is the design should be structured to accommodate change. So here is you meaning to say that you have to implement a loose coupled lah, or a good design that we have learned previously, the four metrics, because when you implement that, it can support any change in the future. It can accommodate any change in the future. Okay, so that is what it means by the design should be structured to accommodate change. So by fulfilling or implementing all of the four quality metrics that we have learned previously. So after that, the design should be traceable to the analysis model. So whatever you design, it must can be related to the SRS or to the analysis that you have done in the SRS. Okay, so jangan tiba-tiba there's a new design even though actually in the SRS there's no requirement or analysis that is can be connected to the design, because maybe you only think of that design, maybe it is a good feature in the future, even though the client never asked for that. So don't do that. Make sure whatever you have designed, it should be traceable back to whatever the analysis that you have done, or your friends or your team have done during the analysis phase. Okay, so pop quiz. Okay, so here, how cohesiveness and coupling related to adaptability? So explain your answer in one sentence. So can I have answer from who else yang I haven't asked previously? Yep, How Wong, Daniel, and Zisheng Wong. The three of you. How do cohesiveness and coupling related to adaptability? I think that one is whatever that we have discussed previously. We already discussed that during the adaptability. So Zisheng Wong, Yap Hao Wong, Daniel. The three of you, please give me answer about this. Or yes, Zisheng Wong, you are raising your hand, right? Okay, the three of you, please acknowledge me so that I know that you are thinking or not, or you are missing in action. The three of you, raise hand. Okay, yes, okay. Still, so you are thinking. Nyap Hawang, but how about Nyap Hawang? Are you thinking? Yes. Okay, good. I give you about 1 minute lah. Okay, so I give you until 4:24. How do cohesiveness and coupling related to adaptability? So just use one answer, one sentence. Okay, so I already have answer from Wong. So I'm waiting for Daniel and Zisheng Wong. Ha, 4:24 already. Okay, so Daniel and Wong, Zisheng Wong. Okay, so while we are waiting for both of them, so we will read Wong answer. Yep, how Wong. If the coupling of a system is loose and the cohesion is functional, it is easily changeable in the future. So meaning it will have a good adaptability lah. Right, Wong? Yeah. Okay, so Daniel and Zisheng Wong. Actually, I forgot lah because previously you all said that Zisheng Wong have some others name that is, but I forgot the name. It is Simon. Is it correct? Simon ka? Zisheng Wong. Another name for Zisheng Wong. So that I can differentiate Nyap Hao Wong and Zisheng Wong. Oh, Solomon. Yeah. Aish. So I will referring Zisheng Wong as Solomon lah after this. Solomon and Wong. Because to mention them with the full name, panjang mo sebut. Yes, Solomon and Daniel. It doesn't need to be a very good words. It just what you think, how the cohesiveness and coupling is related to adaptability. Or both of you are not sure? Daniel and Solomon? Oh, oh, okay. So Daniel already have. Provide high coupling and low cohesion towards the project, so it is manageable to the project if any changing is needed. Okay. So Daniel, it is actually not really correct. Not really. Actually, it is incorrect lah. Because high coupling is a no. Okay, so it need to have low coupling, but it actually need to have a high cohesion. Okay, so the level that have a high cohesion is the functional cohesion. Yeah, backward already. Yeah, so it's okay. So you remember after this. Okay, so remember, is there situation that coupling is better or needed? You mean type of system that will need high coupling lah, right? High coupling, do you mean by high coupling or low coupling? High coupling. I can say for now, it is better to have low coupling. I cannot think any of the situation that we will need a high coupling, because high coupling will give you headache in the future. Okay, so yeah, for me, from my experience, I think high coupling will not be needed in any situation of or any type of software lah. So who thinks that high coupling is needed? Because high coupling is where you will uh, make sure. I mean, when each of the modules is very dependent to each other, so it is actually not encouraged. Really, not encouraged. Yeah. Okay. So Ms. Norshikin also said high coupling should be avoided from the programmer point of view, and then from the ex-programmer. So we really will avoid the high coupling system because it will be headache in the future. Okay, so we don't have answer from Solomon, but it's okay because we on Solomon already. High cohesion meaning codes related to a feature are isolated in a function or module which make it easier to modify without affecting other existing code. Low coupling, modifying a feature won't affect other feature. High cohesion, codes related to a feature are isolated. Okay, so actually your low coupling is already ngam lah. But for your, I need to think about your high cohesion. Codes related to a feature are isolated in a function or module which make it easier to modify without affecting other existing code. Actually, it is incorrect lah for the high cohesion. The high cohesion meaning to say that you group individual component. The component here may be referring to either functions, either module, either procedural, either method. So when you group that component based on its functionality, you group them together because they are working together to achieve one goal. Okay, so when you group them based on their function itu, okay, so it means that you have high cohesion. So it is important for you all later when you do design, each of the module or function that you will create later should be, when you group them together maybe in one subsystem or in one module, make sure that they are actually related based on its function, not based on the previous 6 level that we have learned previously. So yeah, high cohesion meaning you group them together based on the function, not because of the sequence of where you sequence of the execution or the input from the one method to become the output from one method or function to become the input for another function, not because of all that, but you group them because they are functionally related to each other to achieve one goal. So you, because of that, you are grouping the function or the method or the modules to be one component. So that is why you that is what you mean by what it means by high cohesion. Okay, Wang? Solomon. So in short, there Nyap Hawong answer is correct. Daniel punya answer is backward, terbalik. And then Solomon answer low coupling is yes, but high cohesion is not. Okay, so in short, the one sentence uh, that can relate cohesiveness and coupling is to adaptability is for design to have a good adaptability, it must have high level of cohesion but low level of coupling. Only that. Okay, so okay, so the end. So I hope all of you can understand all of the knowledge that we have learned previously today, and it is all benefited to all of you. So if you have any questions or unsure, you can ask in our WhatsApp like usual, or you can do your own research because you are bachelor level already, right? Some of you are better researcher than me. Okay. So if you don't have any questions, then we can end our sessions now. Bye. Okay, bye.